Okay, here we go. Shh, silence, or else it's live. Okay, this is just weird. Start off. So hopefully the vectors were easy yesterday. Like I told you, and especially how I expressed the notes, it wasn't really formulas. It was based on if you just made a drawing of the vectors and knew that vectors can be named by a comma b, or magnitude and the angle displacement. It's chapter 3, chapter 2 trig. Okay, well that changes a little bit. Not a big deal. Very simple formulas that I will have to memorize. But this isn't one of them. This is just an alternative form to name a vector. So what it's based off of is what's called the unit vectors I and j. So I is the horizontal unit vector named by 1, 0 as an endpoint. So go straight right 1. And then j is the vertical unit vector 0, 1. Now it is strange to do this, but we delved a little bit further just to tell you a story about CAD honors with the this format, and it is like nicer to deal with more complicated stuff later. And it really isn't a big deal. But when you get it in this I plus j form, it just it does. It lends itself to do some nice things. So instead of naming this vector 3, 4, we can express it as in ij form as a sum. Because what we could say is, all right, 3, wouldn't you agree that's true? Because what's 3 times 1, 0? That becomes 3, 0. What's 4 times 0, 1? 0, 4. And then what's the sum of 3, 0 and 0, 4? 3, 4. So what I'm doing is reversing it. And then what do we know what 1, 0 is? I. There's that signal. What's 0, 1 the same thing as? J. So that's putting it in what's called IJ form. Okay? That's it. It's really not a big deal. So the only thing you're going to have to do when we do examples of these other things, really you just have to recognize that this is the same as this and then use the AB components correctly further in the formulas. Does that make sense? Okay, so don't really need to show that because that's what we did. So here is the next thing. Strange, out of left field, coming out of nowhere. We're not going to derive it. All this is called is the dot product of two matrices. What? Boy, that was a word that just came out of the wrong part of my brain. Did you hear what I said? What word did I say? What? Matrix. What am I talking about? What is this called? What are these? Vectors. That's it. I had to find myself again. Remember I told you about the brain. Brain a little weird today. A little rough day for Samulus. I was talking to fourth hour. They actually thought this actually happened. And I said, my tires are so bald right now that a grain of sand could cause a blowout. And they actually thought I meant I had a blowout on the way to school and I had to change my tires. But it was just a reference to, okay, I get this message. A reference to my frame of mind right now. You get it? 4 years ago, my tread was this big. I could climb a mountain with my mental car. Now, a grain of sand can cause a blowout. Anyway, let's continue. So, are the children scared? All right. No, you're fine. All right. So, this is simple. Oh, by the way, what's the answer going to be? Is it going to be a vector? Is it going to be a matrix? Is it going to be a number? When you're done with this little evaluation, what's it going to be? It's just going to be a number. Okay, and I didn't get a chance to show that, but here's what it is. You just take the x's and multiply them. You take the y's and multiply them, and then what do? Add those two together. That just ends up being a number. Okay, now I know this seems useless, but this is used in our next formula. So I'm not even going to bother. I like went around the room first hour. Okay, Sally, how do we find the dot product of this? Well, Mr. Samulus, you do 2 times 4 and plus 3. That sounds like Mrs. Samulus. Never mind. 2 times 4 is 8. Negative 3, you get 5. Do I really need to do this one? Okay, but just to make sure that you recognize this format, what I made first hour do was, what's 2i plus 4j really the same thing as? 2 comma 4. You don't have to write that. You just have to recognize, okay, that's the same as just saying 2 comma 4 in component form. What's negative j the same thing as? Ooh, what is it though? It's 0 comma negative 1. And then what do we do next? Well, it's just 2 times 0 plus 4 times negative 1. Then you move on. We're not going to derive it. I don't know if I've looked at the deriving of this before. I just know that it's used in the next formula, so that's why we do it, just so you know. So, the next formula. Look at the end. What does the formula have as a part of it? No. What did we just learn? The dot product is in our next formula. Okay, now I have looked at this and not really derived it. I looked at the deriving of it like years ago, and it made sense to a point, but it is complicated. And you know what it's related to? It's related to the law of cosines, actually. So if I could just, climb into your brain a little bit here, cosine of theta equals, pretend theta was like angle A if you made a triangle out of this. So this dot product can be proven to take the place of b squared plus c squared minus a squared if this was cosine of angle A. Do you understand what I'm saying? Over, by the way, what do these two lines mean? It's right here. The bottom, that'll wake you up in the morning on the internet, takes the place of 2bc, and that's what they can prove in the, in the book, and it's complicated and lengthy. So the product of the magnitudes. Okay, very interesting. I find it. But anyway, this is something you're going to have to do and make sure you mathematically handle the maybe order of operations and the ability to type it on your calculator. I'll stop just in case you haven't written this down. Just for giggles, we're going to go ahead and draw these two vectors just to get a feel, human touch feel to this, what we're actually getting for an answer, so it makes sense in some way, shape, or form. So 3 comma 4, that's this vector that ends right chaw. And then 2 comma 1, which is this vector right chaw. So what we're going to find with this formula is this angle measure. Now notice it said the angle measure that's less than 180, because theoretically, not theoretically, exactly, there's also this angle measure between the vectors in a way, but between, I don't know if that word really works for it, right? So the angle you're getting is the closest angle between the two vectors. So the one that's less than 180. Okay? So that was up in the, rules of this formula, if you want to call it that. So cosine of theta equals the dot product. Illegal teach, I'm just going to tell you. Over the magnitudes. I'm not going to write it like that. I'm going to start doing it. What's the magnitude of vector u? It is 5. So 5 goes here times. It's the product of the magnitudes. What's the magnitude of v? I should call this u and call this v. This is just a quinkydink. Not really, but whatever. What do you end up with this? Root 5. Now we have a problem. And actually, first hour I screwed it up on the last example. I got all discombobulated because my brain's all scattered all over the place. I hit the calculator, didn't open up there. Okay, so here we go. Psh, boom. So you got to be careful. Of course, what button are we going to type? What button are we going to hit? What button do we need on our calculator? It's not cosine. It's the inverse cosine. There you go. So second cosine. By the way, another mistake I made the other hour, but I caught it right away because it was simple. Some of us really need to know that, though. I know I have to finish your quizzes, but I think some of you didn't realize your calculator's in radians, and I find that problematic, especially when you put a degree mark on your answer. All right? You should know that the answers, when you get like 0.3174 when you try to find an angle measure, that you're in radians, not degrees. So check, I'm in degrees, out. Now, it is an issue. Don't do this. Actually, get this done. What's 3 times 2 plus 4 times 1? 10 divided by, and then this is the key. Well, by the way, if you have a fraction button, just do it. But if you don't, you need to open up a parenthesis for the denominator and put 5 times root 5 in it. If you don't put that parenthesis, first of all, you're going to get a calculator error, because what it tries to do is do the inverse cosine of 10 divided by 5. What's 10 divided by 5? 2, and then root 5. So you're actually inverse cosining 2 root 5, which is greater than 1. So that's why you get those calculator errors. You're not typing it right on your calculator. Okay, so 26.6 degrees. And does that seem reasonable for the drawing? Like a small angle measure, right? So that's kind of why we drew that. So you knew and had a feel for what you just found. So the only point of why I started off the notes the way I did is just so you recognize that negative 5i plus 12j is the same as negative 5 comma 12. 3i plus 2j is the same thing as 3 comma 2. Not rocket science. And then what I want to find is the angle between these two if they were graphed on a coordinate plane. We'll do that offline because I think it's redundant. This is where I'm worried about you guys. I'm always worried about you guys. Not in a bad way, I just ponder. 9, right? Is it 9? Did I do that math right? I was always bad at it. And then divided by parentheses. This one actually isn't bad. 13 times 13. And then I think I just close. I think I'm fine. But if you don't have that first parenthesis, you're doomed. Destroyed, annihilated. If you have a fraction button, use it so you don't make a mistake. Okay? All right. Students surmise what's going to happen next. I think it's next. I hope I'm not out of order. Boom shaka-lockers. Okay, so a word came out of nowhere. What's the new word of the day? It's in red, and it's highlighted. Orthogonal. Can everyone say orthogonal? I like how you said it. All right. So orthogonal just means perpendicular in vector land. I don't know. I'm just the informant. Okay. So why did I have the question before I put this back online? How in the world could the expression for that cosine, that angle between vectors, be 0? And this student right here, I'm pointing at him, with help from this student or a student close, is if the dot product equals 0. See? If the dot product equals 0, you have 0 over whatever, I don't care. What's 0 over anything? 0, except 0 over 0. What's that? Of course, it's 1. No. What's 0 divided by 0? Undefined still. But anyway, 0 over any other number is 0. And then when you inverse cosine 0, you get 90 degrees. So that implies by this formula, if the dot product 0, those two vectors are perpendicular. Wrong word. They're actually what? What's our word for the day? Orthogonal. Great. Okay, so then that also implies, what if the dot product's positive? Because look at the denominator. The denominator is the magnitude, which is the vector's length, and lengths are always positive. So if the dot product's positive, you have a positive expression. When you inverse cosine a positive, you get what kind of angle measure? Acute. See, I'm trying to help you so you don't have to memorize this stuff. It's not memorization. There's stuff behind everything. And if you just listen to what I say and take it to heart, all right, then you won't have a problem. If the dot product's negative, you're inverse cosigning a negative. That gives you an obtuse angle. So here's what it says. Now this is what's going to happen to you. I know what happens on the test. I have to memorize the law of sines, area formulas, law of cosines. I might have a problem remembering this. So the only thing you could survive with just remembering what that word means. What does that word mean? Perpendicular. All right. So the word means perpendicular. I forgot what he said. He was yammering about something, and I at least know orthogonal means 90. So let me just go ahead and find the angle measure between these two vectors and see if I get a 90. So here we go. 1 times negative 6 is what? Negative 6. 2 times 3 is what? 6. Now those that know what they're doing would stop right now and say what? So what would I say? They're orthogonal because, this is what you're going to have to write, the dot product equals 0. But I don't know that. I didn't listen. I was scratching my head and looking out the window. Boy, I wish I was out in the weeds right now. That looks like fun. What's the magnitude of the first one? 1 squared root 5 again. What's the magnitude of the second one? And don't do that silly mistake. Just type negative 6 squared and get negative 36. Wrong. What does that become? Don't even do that. What does it become? Root 45. Now, sometimes you have to find, I know this simplifies. That's not the point. Oh, well, actually, you're fine. 0 over, what's 0 over? Who cares? 0. Then you go to your calculator, even though that would make me sad at this point, not knowing the inverse cosine of 0 is. I just did the exact wrong thing there. 90. Oh, so I do get 90 degrees. So then I say, yes, they are orthogonal. So what I did is that the student, when I say prove it, you could stop and say if the dot product is 0, they are orthogonal. That's what you'd write. Or, hey, the angle between them is 90 through my math I just did. So they are orthogonal. So at least you just know the word orthogonal and know what to do. What? Right? Oh, it was right. Correct. I feel like I might have made a mistake. Okay, the dot product. Okay, now this is under the directions of are they orthogonal. But I found this interesting. Let's just find the angle between. Okay, so here we go. The dot product is negative 5 root 5 plus negative 4 root 5. By the way, those that know, orthogonal or not. What kind of angle is between these vectors? Obtuse. Okay, over. All right, now it's time for the whatchamacallit, the magnitude. 5, what? Plus 4, right? Hey, wait a minute. Isn't that, wait, 5 plus 4, right? What's the square root of 4? Or 3, 9. 3. He's nuts. All right. 25 plus, what's 2 squared? 4. What's root 5 squared? 4 times 5? 20. Now, I did this annoyingly with the other hour, because sometimes it doesn't reduce anyway. Sometimes it doesn't simplify. This one actually simplifies real nice. But I'm worried about the calculator. How many people have a calculator with no fraction button issue? Then you are in this problem. Pretend this doesn't simplify. So this is what you have to type on your calculator if you physically had to find the angle between this. By the way, this is what cosine of theta equals. And I screwed this up first hour, but it was fine because I got a calculator error, so I knew there was something wrong. I just couldn't figure out what it was. Second cosine. Now this is negative 9 root 5, right? Okay, so what I did is I put negative 9 root, I feel like I might mess it up again, 5, and then I close that. What does that close? That closes the square root, right? But this is where my mistake was. when I close that, because I just want to close the negative 9, what does it actually close? It closes the inverse cosine. And now I'm no longer, part of the inverse cosine is the denominator. So you know what I need? I need another parenthesis to open up the cosine again. Because all that closed was the product of negative 9 times root 5. And my brain wasn't where it needed to be in the morning to figure it out right away. Someone was saying something to back, and I wasn't listening. It was a lot of fun. 3 root 45. Now I know full well, like I said before, root 45 simplifies, and then the root 5s would have canceled. What I'm saying is sometimes that doesn't happen. You have to know how to work through the roots in doing this formula. Ooh, how exciting. Ah. Okay, so I get 180 degrees. What does that mean these two vectors are doing? Going in opposite directions. Isn't that exciting? And then before I let you ask that question, I'll stop. Do I really have to show an example of when you add two vectors, you add the x's, add the y's? When you multiply a vector by what's called a scalar, how many people have heard that word before, scalar? Then you just distribute it. When you take a negative of a vector, you just take the x's and y's. The x's and the y's, and take the opposite. When you subtract vectors, give me a break. Okay? So there's the assignment. It's on your calendar. We're done. Sorry if I scared you.